t equal to infinity, this is called a steady state error. Let me call it E of a steady state. Okay, and in this case, it's going to be equal to 2 times the value of y reference. Okay, so we basically have 200% error. We wanted to reach here, we reached here. Okay, that's not ideal, right? So in any system that you design, you want to make sure that your steady state error is as close to 0 as possible. You can't just like pick random values here and put here, or like pick random controllers, put here. This closed loop system doesn't guarantee that your error becomes 0 if it's not designed properly. Sometimes it might even make your system unstable. Here, like the system didn't become unstable, but we didn't reach the final value that we wanted. We reached the negative of that, right? So we basically have to calculate our steady state error. One method of doing it is the method that I showed. Writes down the S-domain relationship between y and y ref, take the inverse Laplace transform and make the derivative equal to 0, and that should give you the error in the steady state. Okay, so this is the concept of a steady state error. However, I know that you guys are not a big fan of Laplace transforms, so as I mentioned very briefly before the break, before the spring break, we have a theorem in math that's called finite value theorem. So this is going to be very useful for us. We want to find the sorry, this is not a variable of t. We want to find the error in the steady state. That's basically limit of e of t as t goes to infinity. And excuse me, the finite value theorem basically is this part. It tells us that if you want to find the final value of a bounded function at t equal to infinity, you can do that by taking the Laplace transform of that, multiplied by s, and find its limit as s goes to 0. Okay, so this is basically, it tells us that e at infinity, let me just write this like e at t equal to infinity, which is the steady state error, is equal to limit of s es as s goes to 0. Okay, so this is basically how you can find the steady state error here. Let me use an example to do that for you guys. I hope this was clear. So the finite value theorem, it just tells us that the limit of a bounded function as t moves to infinity is equal to limit of s times its Laplace transform as s moves to 0. Okay, and we can use that to calculate the difference between y and y ref as t goes to infinity. That's called the steady state error. So let's just like use another example to understand the importance of finite value theorem. Okay, so here let's say like we have a general GC of S and GP of S. P stands for plan, C stands for controller. Okay, so E of S is equal to Y, this is E, right? Y ref minus Y. Okay, y ref is constant. I can write this as y ref of s. It's actually like it's not a variable of s, but like it's constant, but it doesn't matter. Y of s is equal to E of s times GC of s times GP of s, right? And so I can write this one y ref s actually this is what we have. It's not right. We have an equation that relates E to y ref. Let's just like take this term to the other side and factor out E of s. So E of s times 1 plus GC of s times GP of s is equal to y ref of s, right? So it means that y ref, it means that E of s is equal to y ref of s times 1 over 1 plus GC of s times GP of s, right? This is the S domain error, okay, for this system. If you had an H here, it would have been a little bit different. You would have like a different term here, but it would be easy to calculate using the same approach that we found. So we found the S domain term of error, okay? So this is what we have. Now, if you want to calculate the steady state error, steady state error is E at t equal to infinity. It's equal to limit of s e s as s goes to 0. So it would be limit of s times whatever we have here, y ref of s divided by 1 plus GP of s times GC of s as s moves to 0, okay? So now it's very easy to calculate, using this formula, it's very easy to calculate what the limit it's going to be. Let's just do it for the previous example where GC was 1 and GP was 1 over s minus 2. I hope I can do this. Let's just like do it on the spot. Limit of s times y ref. That's just like a constant, so I just remove this. 1 plus GC is 1 plus s minus 2, okay?